I forgot to click the go live button in StreamYard, and right now I need to get back to LinkedIn. So give me a
Okay,
second,
yeah.
because I forgot about
think
one.
we are live, but maybe not on LinkedIn. Let me check.
Yep, it should be live now on all of the platforms.
Okay, if people can tell us in the chat.
Yeah. Hello, everyone. Yeah, that was my issue. So I went to LinkedIn to start the stream there, but I forgot to start the stream in our StreamYard streaming platform. That's why I'm returning here. Like, what the hell? Like, why don't I see anybody? But now we should be able to. Yeah, we should be streaming on all of the platforms. Hello, those of you who are watching us on YouTube, on LinkedIn, on Twitch, and other places. Let us know, like, if you can hear us well, if you can see us well, because you might not have the best quality of my session, but everything should be all right with Frank, because I'm streaming from a conference. We'll talk about this a bit later. And Frank has just returned from another interesting meetup. Why don't we talk about your past presentation, Frank? Where did this happen?
Yeah, yesterday I was in Vienna, in Austria, for a meetup organized by a company, Square, SQEUR, a small company of 40 people, and they organized meetups around DevOps and many technologies every month. And yeah, really nice to see that people go to local meetups, 50 or 60 people there. So that's quite nice for meetups where you go after work. Really interesting. I presented Gigabyte on Kubernetes, and other guys presented graph databases, which are also really interesting, always apart from relational databases and SQL databases. And you are at a conference also.
Yeah, I'm in Las Vegas. So generally, if I go this way, that's one of those less famous Las Vegas hotels and casinos. So the view is nice. This is a VMware Explorer. I would say that's one of the largest conference. Many enterprises and many commercial companies use products of VMware. What I'm doing here, there is a satellite event called Spring One. This is one of the largest Java conferences in the United States. A lot of people, like thousands and thousands of people. It reminds me a lot of AWS reInvent. I was at the reInvent only once before the pandemic, and it felt like you're going into that area where the conference is hosted. It's like there are thousands of people just walking around, and the same experience right now we have at VMware Explorer. So yeah, my talk is over. My session was on the first day, but still I'm staying here doing some work, meeting some people, and making connections, discussing how Yugabyte DB can be used with Java. But what's interesting about VMware Explorer, I mean, it's all about multi-cloud. So their primary message, they create several products. They have a huge product portfolio. The primary focus is multi-cloud, and the primary focus is generative AI. The multi-cloud is basically resonates a lot what we do at Yugabyte DB, right? We kind of work in any cloud, but also we are multi-cloud solution. So that's why we also partner with VMware. So that's an interesting experience. Yeah, speaking about the meetups, actually, you said that you had like 50, 60 people. That's a very good number.
Yeah, especially in August. There are not a lot of meetups in August, and usually people are on holiday. So yeah, that was nice. Yeah.
And that also means there is a comeback. There is a comeback for in-person events. Because
I hope so. I want to believe that the problem. Local meetups are different from conferences. Local meetups, people go after work. They don't have to take holidays or anything. Conferences, company must understand the value of it, and maybe that's more difficult with some company. Just because, if it's during work hours, if there is a travel to pay, but at least local meetups are something where you can just go. doesn't need a lot of sponsoring to have a local meetup. Just
Exactly.
if a company has a room to host it, and then pizzas, beers, and that's perfect. Yeah.
Yeah, and hello, Peach. Don't be jealous. I mean, sometimes it's fine, but right now, look at me. I already look tired. I want to go home because it's also exhaustive. It's always better if you have that probably quick experience like Frank had. You just went for one night, for one evening. You meet with the people. You talk about technology, database, and then you're flying back if you're staying at the conference for many days. I have some friends. They have a booth at the exhibition area, and they're saying like, you can no longer do this. It's like they're very happy that today is the last day for the exhibition area, so that tomorrow they don't need to go like and just talk. And those people paid for the booth. Like I'm talking to the guys who own companies. Basically, they paid for the booth to collect leads, right? To collect just different potential users, and they say no, they already exist. But nevertheless,
Yeah,
it's a good trend.
exhibition hall are also exhausting because of the noise and the many people. And
In the United States, I had a quick conversation with one of the organizers for the Atlanta Java user group. So it's one of the largest Java user groups in the United States, and they are saying that they also see a huge comeback. It's like 90 or 100 people join the events these days. It's like they are returning to the pre-pandemic number.
Yeah.
And they said like in August they had a conference. They had a meetup scheduled, but the weather was like bad. It's like they were saying like no way, like we would get like only just a few people coming. But guess what? Like even during the like one of the worst weathers ever, like 60 people showed up, and they were saying like, well, now we are talking. So all right. So my friend, what do we have on our list today? Hotspots. So how about you doing an intro? I mean, like, what's the point actually? Why do you want to discuss this?
Yeah, that's something where we have questions sometimes, and that's the kind of questions where even if not everything is described like the table schema, the descriptions of the description of the symptom rings a bell because that happens sometime. So the idea is that people start a workload on a distributed SQL database and then expect that if they do everything correctly, like connecting to the multiple nodes because of the load balancer or the driver or whatever, they expect to see the same loads on each node of the server. And this question was like, I think I did everything, but I see high CPU usage on one node and the other looks like they do nothing. And yeah, this is what we will discuss, hotspots, because the database tries to distribute the connections, the data, and the SQL processing, but that also depends on the access pattern.
Yeah, can actually, speaking about some common definition, can we refer to this type of problems as the load skew and data skew? Because this is what I think. Yeah, it's
usually
like
people talk about hotspots because that's the term we use also in even in traditional databases where you have only one node. There's some kind of data access where only one block is always accessed. So yeah, you have a hotspot somewhere, but different term and different definitions.
Yeah, the hotspots, but also when we're talking about the hotspots, it can be like way too generic like problem. So we don't want to boil the ocean today. Generally, what we discussed, what we decided to show to you folks with Frank is like a couple of not typical, but a couple of situations where that can lead to the data skew and then following load skew, like because the data skew is where you have your data, and the data, it happens that one of the nodes gets more data, right? And if one of the node gets more data, then it will get more load by definition. There is a dependency. So like we will show you one of those situations when the problem was at the application and the database schema level, right? Like how you define indexes. And the second option we will show you like when it's related to the driver. So it also can be the driver can be a reason, and your deployment option can be a reason. And finally, we will show you that sometimes it's not about your application, sometimes it's not about your middleware, drivers, etc. It can be related to the operating system. For the operating system, we don't have any specific demo, but at least we will walk you through one of the interesting articles that was created by Fritz Hoogland, one of our best friends and database experts. So why don't we do this? Because our flow will be as follows. We will start with your use case, right, Frank, first, but we need to get prepared for mine, for the second one.
So start yours, and then you can run the load, and then we can switch to the other one. Yeah.
So yeah, today I have just one screen, folks. So that's why like you will see me switching different windows. Where am I? Where is my Yuga by DB manage? So like I'm going to have I have this Yuga by DB manage cluster running across there. Yeah, several regions in the United States, but the regions don't matter a lot. And I want to do this. I will be using Performance Advisor tool to collect any performance tuning recommendations, because I have a special workload, and by default, when you run that workload with one configuration that can be used by you by default, you can see some interesting suggestions related to the data skew and load skew. So the application might be already familiar. You might be familiar with this application. It's like this market orders application that we use from time to time during our live streaming sessions. It basically takes and streams market orders from some endpoint into our database. So my command, let me just start this application, and then if you want to see any hints and suggestions from the Performance Advisor, we need to run our workload at least for like 10 minutes or 5 minutes. It's suggested to run it for 1 hour, as it's said here, but we will be running for like much shorter period of time. So let me start it. I want to make sure that it gets connected to the database. Yeah, it gets connected. And right now, yeah, we already had some trades there, and it will keep streaming. So we will return this. If I run, let's say, their Performance Advisor right now, I will not see any suggestions.
So in the Performance Advisor, there are some recommendations that are based on the static analysis, but some recommendations need to analyze a workload to give recommendations here.
Exactly. And for the load skew, for the hotspot scenarios, right, we definitely want to run it for some prolonged period of time. So like that's my preparation. That was the preparation phase for the second use case, for the second demo. So right now, let's get back to yours, Frank.
Yeah, I will share my screen in my turn, and here is a question we had on the Yugabyte forum. We have many different channels to talk to users. Of course, the users who have support have a direct channel, but open source users can contact us easily on social network, whatever. But we have a Slack channel, and we have also a forum. So that's a way where we had this question with a good description of what is happening. That's always good if you describe what you see when you ask a question, because sometimes in your context you know what you are talking about, but to understand, that's good. So that was exactly about what was
this is a good example, right? This is a good example of how you need to ask the questions, provide as many details as relevant.
I love that, because you see, I mean, the basic questions are answered there using the smart driver, load balance, replication factor free, free tablet servers. So yes, you can expect a distribution of the loads there, and primary key, composite index. So they didn't provide the schema for the table. Of course, it's always good if you provide the schema for the table with a /D, for example, but already good information. Primary key index, composite index. You see that already the user that posted the question already thought about what can be different from another workload. Execution mode in batch size 500, and insertion. So basically, they insert by batch of 500 rows, and they expect those rows to be distributed on the cluster. However, they observed that one of the nodes is going to high CPU usage where the other are doing nothing, which is not what you expect when you scale out. And
yeah, so basically one of the nodes, right? One of those nodes became a hotspot. It has a hotspot, and generally this is a good representation example of the load skew scenario when you have, let's say, multiple database nodes, but there is the load skew because one of those nodes takes significant chunk of the traffic. So that's good.
yeah, and then
okay.
yeah, sorry.
No, go ahead.
And then, so the first thing I asked was the schema, because I got an idea about something about the composite index, and this is where I see that I got already an idea of what may be happening, and this is also why I explain what to look out in the UI. But what we will do now, I will reproduce it. So reproduce a simple table and doing what I understand is described there. So
okay, so just one you said that you by looking at these details, you already had some assumption. Like, what was your first assumption? What that could have been?
Yeah,
how could you connect all that shit? Yes.
My first assumption was that because the primary key is composite, then you have some parts that are the partition key, but not the whole, maybe, depending on how they define it. So this is just an assumption, but the best is to reproduce it. I always like to reproduce problems on a small lab with a small table with just a minimum to reproduce the behavior so that it's easy to troubleshoot and understand, and maybe show, because for the user, maybe it's not so easy to provide all the information, the schema. Maybe they have tables, they have to change the name before putting that on a public forum. So we can also do it the other way. I can also show what I understand, my small test case, and ask, do you observe that? And then it's a confirmation that we see.
Makes sense, my friend. And we had a hello message from Eshwar. Yeah, thanks Eshwar for joining us, and good evening to you. As far as I remember, you joining us from India. Just let me know if I'm right here, and we are happy to see you like coming to our events regularly.
Yeah,
so
yeah.
Probably one at some point we need to discuss what are you doing with Yuga YDB, right? Why not? So that we learn if you're building anything with Yuga.
So I will connect to a 3-node cluster I have on a lab on the cloud. So just defining the Postgres variables and connecting with PSQL.
We don't see Frank. We still see the forums question.
Yeah. Okay. Yeah. Good point. So let me
just share your entire screen. Show us everything what you have, like all your.
Yeah, I thought.
Oh, is
this is what I did.
Is it private, like something private, something like if there is any criminal,
No problem. I will. I thought this is what I was doing, sharing screen. Let me try it again. Entire screen. Yeah, should be this one. Yeah, probably I shared only the window. So here I'm connected to a lab. I just connect with PSQL, and I will create a table as what I understand with it. I will generate a UID, so I create the extension if it's not already there, but it is there. And what I understand is that they have a table, they have a composite primary key. So I create this composite primary key on A and B. I define A as an integer and B as a UID. This is something typical that you find, for example, if you are doing software as a service, multi-tenancy, where you want to put everything in the same table and you have an identification of the tenant, for example, and then an ID for the application object. So that's quite common.
So yeah, let me repeat this so that I understand. So the A column is for your, it's going to be your tenant's ID, right? That's the idea.
Yeah.
It's your tenant's ID, and then B is a record ID.
Yeah,
Okay.
it can be. Yeah, that's usually a case for composite ID. And then, so they said in the forum that they were inserting. First, they have, I want to time it, and they are inserting into it. And this is where is my guess. My guess is that they were inserting for the same value of the first column, exactly like you are doing multi-tenancy. You define the key on the tenant ID and then an ID, but you insert for a specific tenant.
Mm-hmm. But in that question, just to clarify, in that question on forum, that was not a multi-tenant use case, right? They did not say that that's a multi-tenant application.
I don't think they explained directly what it was. That was more my guess from the composite key and the symptoms of hotspot.
Okay, yeah, because like when you truly have that multi-tenant application, it naturally can happen that one of the nodes will get more data, more traffic, because one tenant can be bigger than the other one. But in this case, yeah, you're just trying to reproduce by taking this as an example, right?
Yeah, but even in multi-tenant, you want to distribute. That's a difference with database sharding, for example. If you do database sharding with Citus because you have 3 or 4 tenants, then you have one database for each. But if one tenant is bigger than the other, then one database will be bigger. With Yugabyte, you may choose to isolate physically some tenants, and then yes, they will be on specific server, maybe specific regions. But you may want also to distribute everything because you have many tenants and not all active at the same time, and you want to optimize your resources so that all servers are used, even if not all tenants are used at the same time. So yeah, can be the case in multi-tenancy in software as a service. Can be the case that you want to distribute everything also for a single tenant.
Okay, let's get back to your demo. Yeah, like what's
and
next?
then so I'm just running my insert with a watch in PSQL to run it a lot. So it's a small lab, so the latency is not very important. What I want to see if I created this situation where I expect something with a hotspot because I'm inserting only for one value. And then I want to see how to validate this assumption quickly from the UI. If I look at the Yugabyte D UI, which looks like the YBM, the YB managed service UI, there are some additional features in each of them, but that's the same idea. Basically, if I look at my nodes there, I see the 3 nodes of my cluster there. And I see the read and write operations. And I reproduce the case where I see a lot of writes in this one and nearly nothing in the other. Those are the operations.
I think for the second one you have this 0.4. That's just some UI bug or some bug, because that node also I think doesn't get any traffic. But yeah, like that's a good example. And by the way, folks, if you see this UI for the first time, Franck and Denis did a community episode about this new monitoring UI like a couple of months ago. So you can go to our YouTube channel, live tap, and you can find one of those recordings. That was a nice session where we just tried to use this tool for various scenarios.
I don't think this is a bug. I have nothing else running on the lab, but there is the statistics snapshotter that puts statistics in a YCQL table. The statistics that you see, for example, the statistics that you see in the different metrics there, they are gathered by Yugabyte and stored in Yugabyte also. So maybe those writes, those small writes, are those ones.
But why don't I have the same for this node? Why the third node has 0? if it also needs to update the statistics? It's actually a good question. Probably we need to
yeah,
dig
we
into
will look
this
at
deeper.
that after. We will look at this system
Okay.
table and its tablets and its distribution. My guess is that maybe the timestamp is in the partition key, and then when it snapshot the statistics for one timestamp, this goes into only one. But we will validate that later. That's a good case.
Or it might be, a preferred region. This node on the south might be your preferred region. That's why. Anyway, let's not guess. Let's carry on with the main demo for the hotspot.
Yeah,
we have the hotspot. We have this hotspot.
we will look
we
at
have the
my
load queue.
demo table, but we will look at this one later if we can see also information about it. But basically, what I wanted to show is that this is about the dynamic behavior, the distribution of reads and writes. The distribution of the tablets is okay. I have the same number of tablet peers in all nodes, the same number of leaders. So my data, my tablets are well distributed. The problem is that my workload is not distributed everywhere. And then to understand better what happens there, the best is to look at the definition of the table. That's always something good if you can include a /d of the table that where you think the problem is, because we see the columns, but we'll see also the definition of the indexes, but the full definition. I didn't define anything in my primary key. If I look back at the create table, I just say primary key A and B, but we have some defaults there. We just take the same syntax as Postgres, where you do not mention anything about sharding, and by default, we apply hash sharding on the first column and range sharding on the second one. And this is something that you see easily when you look at the definition of the table. The primary key index shows this. But that's not sufficient to understand the behavior, except if we know something about the storage, that if it is hash sharded, then the partition key is only the hash part of it. And to understand
if you show your insert statement, because that was a synthetic test, right? You purposefully set the first column to 1.
Yeah.
Which is obvious, and that's why, let's say, all the data went to one of those nodes, because we need to have one of the columns to be our hash key, and this is what can happen, right? That's probably what happened in that scenario with the user, because there might have been some value that was repeating frequently, right? Something, and that led to that load skew.
But that's important. This is not explicitly mentioned here, that the partition key is only taken on the hash value. We can see that in the other UI, the UI that we access on the master on port 7000. If I look at the tables there, here is my demo table. And we have the internal gigabyte information about this table. First, we know that it is a PGSQL table coming from the Postgres API. We have some information about the replication, so going to each zone. We have information about the tablets, but this is the most important for the problem we have. Here is a list of the columns, A, B, C, with their data type within the storage. Those are not the Postgres data type. Within the storage, they can be stored as integer or binary. Nullability, as in Postgres. But what is important here is that even if from a SQL point of view, my primary key is on A and B, from the distributed storage point of view, the partition key is only this one. And
you can
B
have
is not part of the partition key.
Exactly, and that led to that load skew. So like, what are the
Exactly.
options? How can we fix this, and how that user can fix the issue that he or she observed? I don't know, like whether that was
Yeah,
he or
I
she.
will show that just changing the primary key. First, if you want to understand more what happens, you see also that the tablets are defined with ranges of hash values. And yeah, let's do that quickly. If we have a function to show the hash value. So first, just validating that in my table, I have all rows in A, and I have 2 million of rows there.
Oh
And
my god.
and this value 1 has a hash code of 4064, which I will put as hexadecimal, because this is how it is displayed. So this is the hash value in hexadecimal, and this is where you can compare to the range. So was 1210, then it goes there. The leader for this tablet is on node 39, and then I'm sure that this hotspot was on node 39. Yeah, that was the case. So the value
I love those.
is
I love
hashed,
those functions.
goes to a tablet and goes to the leader, and then all my inserts was all sent to one leader, even if my table is split into multiple tablets. So what we can do with that, let's just recreate the table. So what I said was that if we have a hash sharding, then the hash only is used as partition key, but we can have more than one colon in the hash one, and this is the syntax. So this is extended syntax. This is not Postgres syntax. This is a syntax that we have extended to be able to mention that the primary key has 2 colons, but it's a hash of those 2 colons that will be the partition key. And I can have more colons later, but the point is that the partition will not be determined only by A, but also by B. And now
Excellent.
if I insert...
Actually, I did not know. I did not know that we support the calculation of a hash code from several columns. Now I'm curious about the implementation and about the supported data types. For instance, can I have one column of the int type and the second one of the text type? How, if we support this, then how can we calculate the text the text column hash code?
I think
Okay.
one way
You already
is
have an
to
answer?
calculate it. Let's say 42 as an int.
Uh-huh.
I hope it works. I never tested that. And
it's okay to fail. I mean, yeah, let's try to
yeah,
fail.
and the text, and let's say that's a timestamp.
Okay.
Does it work? Yeah.
Oh,
so I
wonderful.
have a hash code
Wonderful.
for that. So we can hash any data type. So
Cool,
internally, there
That's
is a transformation to something that is binary, and then a hash value applied on that and on the concatenation of it. So in my case, if I run my inserts, now it will go to a partition that will be determined by A and B. So A is fixed, but B is generated from random. And then I expect my insert to be distributed in all the tablets. So if I go back to the UI, first the one with the table definition, just to check the difference in the definition. That's the only difference we see there. The 2 colons are part of the partition key. Before, the B was not a partition key. And I still see a hash split there, except that this hash value is calculated from both of them. And then if I look at the servers, I guess that the write operations, yeah, that's perfectly distributed.
Yeah, let me applaud you. Excellent.
And I don't remember what was the throughput before. I think it was something like 25 or 28 on only one node. And here we go faster and all on all nodes. So yeah. Of
Yeah,
course,
I
that's the
remember it
goal.
was
The
like,
goal of
yeah,
distributing is increasing the throughput. Yeah.
wonderful. To summarize, right, the issue was that was a hotspot. One of the nodes was storing more data and processing more requests, and eventually you were overutilizing one node and you were underutilizing the others. And in this case, the problem was related to your schema, to your index, to your partition key, like the way how YugaByDB partitions your data. And just folks, you can rewatch this later, and probably we will create a few curated cut videos. You just start if you have all of those hotspots, etc. It's up. Let's start from your application level, start from your schema level. Check that everything is set up and configured properly. And what Frank showed you is what that was the schema level issue, the partition key issue.
And also, if we can add, if people test it, we are interested also by the feedback. For example, you have seen that I had to go to this other UI to get more information. For the moment, we have information about the tables. I can see my demo table, but for the moment, I don't think we show more information about the tablets there. Maybe that's too internal for end user UI, or maybe not. So the feedback is also interesting from people who test it.
Yeah, we'll
Okay,
see. We'll see.
maybe we can switch to your workload.
Yeah, actually, that's a good point. Now we will take a look at another potential issue that can lead to hotspot.
So before my demo, what you did was running a workload and then let it run to see if the performance advisor finds something.
Exactly. The application is still running. To remind you folks, what we did in the beginning of the live stream, we started this workload. It's a write-heavy workload. We capture various market orders and we put them into YugaByDB cluster. Like we already have 30,000 deals and trades closed. So now that's my cluster. To remind you, I have 3-node cluster. That's a multi-region cluster across United States, East one, 4, and Central one. Speaking about the performance advisor, yeah, like there is a traffic, there is a good. Like, that's not. It doesn't utilize all the resources because probably I'm streaming from one application thread, but nevertheless there is some load. Let's go to the performance advisor. Let's see like if we have any suggestions. Because we were running this for almost 20 minutes. I bet I should see some suggestions. Waiting.
We'll see. It's also scanning many different things. It's also scanning the schema, for example. It can give some recommendations. There are some data types where there is a good chance that sharding is not a good idea. It gives that. Okay, so you have something.
Yeah, now take a look at this. Take a look, just try to comprehend this. It said that one of the cluster nodes in one of the region processed 1,700,000% more queries than the other node in the past 1 hour. Basically, yeah, I had the read workload, I have the write workload, but generally most of the requests are being forwarded and processed. At least they are forwarded initially and processed initially by one of the nodes. And this is actually, that's the hotspot and that's the load skew situation. So let's try to dig into this use case because first let me actually follow your pattern, right? Because first you check your schema. You want to make sure that your partitioning, your partition key is a good one because I just want to exclude or confirm the situation. Let me go to the connect cloud shell YSQL. Oh yeah, like I need just to let me remove my screen. I need to find the password because I don't remember it, and I'm going to reuse this cluster. That's why, folks, I don't want you to see my password.
Yeah, when you start a database on YB managed, you can have a generated password and then you save it, or you can put your own password. But of course, If you forget the password, I think you have to ask support. I'm not sure.
No, I have it. I always have this password. It's just stored on my laptop. Okay, so for some reason it takes us, yeah, so that's my schema. I have, there are several workloads, but right now we are dealing with this one, trade table. So let's take a look at the trade table. Do we have any issues with the partitioning key? Let's do what Frank did with his usage scenario. I think I have this latency because this is a multi-region cluster, and probably the preferred region is somewhere else. But usually it works much faster. I don't know like why it runs
Oh yeah.
so slow now. It's anyway. My primary key is ID, just ID, and this is the integer number. So it's all right. I mean, like the
and we see that
distribution
it's
will
coming
be-
from a sequence. So yeah, that should
Yeah, that's the sequence. Yeah, that's the sequence.
that should
So
distribute
generally,
the rows. Yeah.
yeah. So generally, I should not have any. It's not the issue that we discussed with you, Frank, before. But here is what you also need to check your connectivity settings, right? Before you check your application logic, before you check like if you have any bug in your application logic, check your connectivity settings. In my case here, let me just stop this application for now and show you the configuration. I am connecting using this properties file, Yugabyte properties. So let's open it. Let's take a look at it. Cat properties, Yugabyte DB properties. And here is I'm using PG simple data source. That's my class name. So what that is, this is the PostgreSQL driver. And originally I created, when I was creating this application workload, I was creating it both for Postgres and Yugabyte DB. And by default, I use the Postgres open source driver. And the PostgreSQL open source driver, that it doesn't load balance your requests. So generally,
for a good reason, because Postgres cannot load balance. There is only one writer.
Exactly. And I reuse this as an application developer. I'll reuse this driver, and that driver it also can lead to the load skew, but that's not, let's say, the data skew, right? Because the data is distributed across all of the nodes equally well. But initially, the request goes to one of the nodes. So generally, my application is connected to one of the nodes, to this one. And this endpoint is the load balancer on the Yugabyte DB managed side. If I go to the settings, I have 3 nodes, and if I'm connecting through this node, generally, I still will be able to see the other nodes. It's like we have this select from YB servers. So I have these nodes visible, right? And they have the IP addresses, internal IP addresses in the cloud environment. But the PostgreSQL driver will not be able to benefit from this information. It still will be sending all of your requests initially to one of the nodes, and then that node will forward this request to the other nodes, right? If the data is stored on node number 2. So that's the issue, and this is the driver-related issue. How can we fix it? The fix is easy. Just switch to the Yugabyte DB smart driver, because what the smart driver can do, yeah, let me do this right now. The smart driver still will connect to this single endpoint. That's not a problem. But then, once connected, the driver will find the IP addresses of the remaining cluster nodes. So yeah, that's the driver. It's called YB cluster aware data source. That's for those who use Java. If you use other language, we also support Python, Go, etc. So let me save it. So the driver will be connecting to this endpoint, but once connected, the driver will learn IP addresses of the other nodes, and the driver will start distributing all of your requests initially, like across the cluster. So let's do this now. I fix the driver, and if I restart the application this time, it also will connect. There is our driver is basically built on top of the PostgreSQL driver, and right now the traffic is load balanced. The initial query is load balanced, right? And generally, if you keep running this for some time, again, we don't have this time right now, but if you keep running this for like 5 or 10 minutes, eventually you will see that when you do, you can say the resolved, right? And when you rescan this in 5 or 10 minutes, you will not longer see this warning, the suggestion. So right now, I think I will see it because it's like at least it might store this information for 1 hour, and still I just restarted the application a minute ago. But let's see what happens. Yeah, it still says that like the number has changed. You see the number decreased, right? Before we had 1 million something. You remember?
Yeah,
We had 1 million something. Right now it's just 180,000, which means that the driver configuration helped us, right? So right now the queries go to different nodes, and then depending on where a primary copy of a record is located, then the request can be processed by the node that received the request, or that node can forward it to a different node. But that's how you fix it. So that was another use case, another reason. Check your driver, especially if you're migrating from Postgres. Especially if you have an existing application that already uses the Postgres open source driver, switch to the smart driver.
And we have a remark from Pete, who says, because he already gave feedback on that, seeing us jumping between PSQL or YSQL SH and the web interface, it would be good to query all this information from the database. So the metadata, the statistics from the database. And yeah, that's right. For the moment, we don't have that. I can show something that we have, and I don't use a lot, but the support use it. There is a Yuga tool. Did you use it, Denis? Let me share my screen.
What's that? Yuga tool?
Yuga tool is something we have in the repo that we can run in command line, and that can list, for example, the tablets and many information. This is more used by the support, because when you do support, it's not easy to access a UI, and you don't want to ask screenshots of the UI. So this tool was made by our colleague in the support to gather information from the command line. So it's not available as SQL queries, but it can be available from the command line. And actually, I have seen that because we had a colleague who had a question, and in our internal Slack, he pasted a query, a SQL query, with this information about tablets. And then when I've seen that, I was like, oh, we have something that I didn't know. And thinking about Pete asking for this SQL interface on this information. But actually what he did was using Yuga tool and piping that to SQLite to query it with SQLite. So this is how he did a query to see this information. I think at some point we will have something like views in Yugabyte to see that. The thing is that we need to think about how to do that, because we need to see from one node the information from many other nodes, and everything we implement, we want it to be scalable. We have users running with 3 nodes. We have users running with 1,000 of nodes. Do we want to give a simple view that people query without really thinking about what is behind? Do we want a simple view that can read from all the nodes in different regions? So we have to think about that. But yeah, that was about the question about showing the same information, but from a SQL interface from the database. That's something, for example, that people working on Oracle have. There are a lot of $V views and $GV views to see the big picture. Yeah, it's handy when doing demo. We don't have to switch between UI and command line, but we need to take care that it doesn't overload the cluster.
And that page is a public page. So like if you share this page link with those who are watching us.
I just
Yeah,
Googled
let's share
from
it.
that's a page from our support. Let me put that in the chat.
Yeah, well, and also you need to put it in the LinkedIn chat directly. Just a reminder.
Yeah.
Yeah. Okay. All right. That's interesting. Yeah, Pete, check it out. See like if there is at least some something that simplifies to achieve what you're trying to do, right? So just let us know. Okay. So yeah, folks, keep asking your questions, keep sharing your thoughts. We don't we always have an agenda, right? Because we do prepare for our live streams, but we are happy to discuss what's on your mind, what bothers you. So keep this in the mind. In the meantime, we have the last use case, right? So what we showed, you showed that the load skew can be caused and the hotspot can be caused by a poor index. Like you need to fix the index, right, to get a better data distribution. What I showed that was the load skew was caused by the Postgres open source driver that is not cluster aware. It basically doesn't know all the IP addresses, and it doesn't. That was about the connection like skew, right? Because there was just one single node that would receive all the requests, and then that node would distribute the request across the cluster. We fixed this issue by switching from the Postgres open source driver to the Yuga by DB Smart driver, which is also open source. And what else can happen? You certainly can have some bugs in your application logic, right? There might be some issues in your middleware. Just keep checking like everything, like until you get to the root cause of your hotspot. But also sometimes you might have checked everything, right? You see that your schema is perfect. Your partitioning key is great. You don't have any issue with the driver. You don't have any issue with your application code, and etc. What else that can be? It can be operating system, or it can even be hardware. That's also the case. So sometimes you might need to dig into the details and into the statistics of your operating system and hardware. As an example, right? As an example, we have not prepared any demos, but Fritz Hoogland, our close friend and a database expert, he loves to publish a lot of the articles on the internals and how you need to how you need to use various operating system level tools for performance bottlenecks, troubleshooting, and for hotspots. And this article is about one interesting use case. Like this article is not about the load skew, right? The load skew when one of the nodes gets a lot of the requests and traffic, but this use case is different. Like that also was a sort of a bulk ingestion, like in batches. What he's discussing here, that's some real use case, some real production use case. And eventually he was like, whenever you do any write in Yuga by DB via transactional database, right, Frank? And we need to fsync your updates to the storage level.
Yeah.
And as Fritz concluded, usually we spend like 20 milliseconds or more when we do batch-oriented work and use Yuga by DB when we do this.
Just to explain quickly, fsync is the sync to the disk. We sync to the other nodes. That's the replication. And that could be sufficient if a majority of nodes is always up. But in case of, for example, a disaster, a region where all the disks are lost, if we do not sync to disk, then persistent data may be lost. So we need to synchronize through the network, but also be sure that what is written to the buffers in the OS goes down to the disks.
Exactly. And then what Fritz shows, he shows us how to use operating system level tooling to identify different potential issues in your operating system settings or your hardware, because it's not all about Yuga by DB, right? Or it's not about your application. It can be like the bottleneck, the hotspot can be down below in the operating system or even hardware. So generally what he does, he says that Yeah, like YugaByteDB runs, like YugaByteDB server runs many threads that's doing writes to disk, that doing fsync to disk, and generally it's a little bit harder to trace individual fsync operations, but we have that vectorized write v system call that is used for the batches, and that one is easier to track. So generally, Fritz uses strace tool, and here is he found a couple of interesting writes, and he says like that when you fsync, when you do the fsync of a batch to disk, let's say there is the first call, and that call basically fsyncs just 28 bytes of data, and there is the second call, always the second call that fsyncs I don't know 162 bytes. It's like around like 1 megabyte, right? 1.5 megabyte to disk. And this pattern continues, like he's inserting different batches of data, and that's always the case. A batch and that fsync is split into the first part of 28 bytes, and then he has 1.5 megabyte. So what the issue? Like he kind of, and this is actually the problem here is not the load skew, but the problem is that it takes around like 1 second, right? Like a lot of time. It takes a lot of the time to fsync this batch to disk. So, and he starts digging deeper. Then he uses the tool called BioSnoop. Have you ever used this tool, Frank? I've never used it. I know
No,
Strace,
never,
but
never.
yeah, and that tool actually allowed him to see how those writes fsync requests look like at the block IO level. Like, you know, he goes really deep. I mean, it's like so this is what he sees, right, with this tool. There are requests, like the first request is like for just one for 4 kilobyte, but then you have 26 kilobyte, 26 kilobyte, 26 kilobyte, right? This is, oh no, it's byte. Yeah, 200, 250, 260 kilobytes. And this pattern continues. Like for this small writes, it takes, you know, just 60 milliseconds to do the fsync, but for the bigger ones, the issue is like 3, 3, 3, 3. So he's inserting some batch, right? A lot of data, but then at the block level, it's split into these batches. And this pattern is suspicious. Like why, for instance, if I'm inserting 1 megabyte, if I want to fsync 1 megabyte, why cannot I, you know, I'm just store this one? Why cannot I just fsync that 1.5 megabyte to block IO right away? Why the operating system splits this into these calls, right? So that looked suspicious to Fritz, and he kept digging and he kept digging, and eventually he found this configuration setting. It was related to the max sector size in the operating system. So it was hard-coded, it was configured, it was set to 256 kilobytes. That's why when he was trying to fsync a batch of data, a batch of changes, and the batch size was around, well, let's say 100.5 megabyte, but eventually at the block level, there were multiple calls, and the maximum size of that block IO call was around 250 kilobytes, and that basically kind of, and that was leading to that accumulated latency. And he wanted to achieve differently, and he just was trying, all right, if that's the case, let me change this max sector kilobyte size to a much bigger value, right? So that I can just minimize the latency. But he failed to do that. Why? Because he was running on Amazon EC2 instance, and this setting was hard-coded. It was impossible to change it. So generally, that's why he had that latency. So what's the lesson here, right? When you're running, when you're working in the cloud environment, even if you use some virtual machines, you might not be able to use and enable all of the options. So he truly wanted to increase this option, but it was not possible.
Yeah.
When you're running in your private data center, yep, it's more.
But at least with Linux, you have tools to investigate. I see that we have a question.
That's right. That's right. Like at least think like the point of this article is to show you that if there is no any hotspot or load skew at the application level, YugaByteDB level, or other layers, then keep digging into the operating system and hardware. You have the right tool. Linux comes with wonderful tools, and this article just shows you how your investigation flow can look like. He found the root cause. Unfortunately, it cannot be fixed at the operating system level because it's just running on Amazon EC2. They do not allow you to do that. But generally, yeah, like then I remember that as a result of this investigation, we were planning to introduce some of the optimizations on the gigabyte DB level so that we can live with this limitation, but still minimize the latency in the cloud. So the question you said we have.
We have a question that is not related to that thing, but that is interesting also. Question from Eshwa. Imagine so we have imported the data set, and in my demo I changed the primary key, but you can also think about at some point you need to change the data type. For example, you made a mistake, you defined the integer and you reach the limit, and then you want to use a big int, for example, or something like that. How to change that? And that's an interesting question, because in Postgres, DDL is transactional, so you can change it. But the problem is that even if it's transactional, doing multiple DDL or DML within a same transaction atomic, it will lock the tables. And in Yugabyte, because we are distributed, we don't like to lock the tables. So I have a blog post. Let me share. I will share the URL and share my screen also to show how I changed the type of colon in a Yugabyte table without this atomic DDL. Usually when we change it, it's good to do in different phases. You usually don't want to do the DDL phase at the same time as the DML phase if you change a big table, because the DDL is short but may have to lock the metadata. The DML can be long if you really have something that has to change the type on each row. That will be long, but it's more transactional because it doesn't lock. So the idea, I have in this blog post, I have just an example where I define a data type, integer, and then I do that in multiple releases, because you can imagine that you already have the application running, all that. So the first release will add a new colon with the new data type. I change it to big integer. And that's quite fast. Adding a colon is quite easy. There is no default value to set on all of them. And then you backfill this new colon with the value. That can take time, but it's not a problem because it just runs without blocking anything. So those are updates, and you may want to define an index on it to do that faster. And I'm just going fast. I have somewhere where I defined a trigger also to define it automatically. And at the end, at some point, when you know that you have two columns that are synchronized because you do this backfilling and you created a trigger, then you can move to the new one. And this is another application release where you just rename the column. Maybe you want to keep the old one just in case. So different phases. And this is what happened with applications. You do not change those big things in one application release. You start by adding a new colon. If the application can put the value in this new colon, then you change it in the code, or if not, you use a trigger. And then when you know that everything is done, you can switch to use the colon, and at some point remove the other one. So that's how we change the type. Of course, it's always better to think about the data type before loading a lot of data. Do not use integer, use a big integer. It takes just a few more bytes and you don't have a limit that you will reach. But if it's not the case, if you have to change the data type, that's possible in multiple phases.
So the lesson that you gave us, even though Postgres, YugaByteDB, and other relational databases support changing a column data type, usually we don't do this in production. It depends on your workload in production, because the DDL can impact your performance and throughput dramatically, especially if you want to change. You're changing your data type of a column, and if that column is also indexed, come on, it's your users and your users might not be happy. That's why, yeah, like that's probably a more practical advice, how you kind of approach this with the minimal impact on your production workload. But yeah, it's possible to change. Like you can use the alter table like command, right, to change the data type in Yugabyte DB. You feel free to do that. But if you are working on a heavy, like on an application, and that application has a lot of reads and writes, then think twice before you want to do this in production. Probably you need to follow your approach.
Okay, do we have
and,
other questions?
Yeah,
No, I don't
yeah,
think so.
Yeah, that answered Ashwar's question. Yeah, folks, the official time is over, but we are happy to stay here for extra questions if you have. And we do know that we also have some things to do today, whether it's early morning, evening, or late night for you. But if anything else is on your mind, we are ready to stay here for one extra minute. And if you have any new question, you can answer it. Otherwise, we will close our stream.
But we are
nice
still
exercise,
open
actually,
on the community Slack, on social network, on the next episode. So yeah. All questions
And the next
welcome.
episode is coming. The next episode is coming. In a couple of weeks. If you have actually suggestions, what you would like us to discuss, what you would like us to show, you can just tell us right now, or just go to the community Slack and share your thoughts, and we'll get ready. We always do this, right?
Or feedback. If you test Yugabyte and you want to give any feedback of things that works, things that doesn't work, things that could be better, that's also a possibility.
Yeah. All right. Looks like we don't have Frank. Could you double check one more time? Any questions on LinkedIn before?
Yeah, let me just refresh, because I've seen that the problem with LinkedIn, if you do not refresh, you may not see the latest comments, but I don't see new ones there.
All right, which means that we are all ready to go and continue the rest of our day, evening, or night. Thanks for joining, folks, and thanks for joining, Frank. See you in a couple of weeks.
Yeah, see you.